Okay, welcome back. We are looking at question 3. This question appeared on both the AB and the BC exam 2025 free response. This was a non-calculator question, and the general gist of the question, we have a student reading a book and continues reading for about 10 minutes, and there's a table of values given, and those values are really for the rate at which the student is reading, so in words per minute. So part A asks us to approximate r prime of 1 using the average rate of change of r over the interval 0 to 2. And so all we're going to do in this case is say, all right, r prime of 1 is approximately the value of r of 2 minus r of 0 over 2 minus 0. And if we use the values in the table, that equals 100 minus 90 over 2. And so that gives us 5. Now, that also asks for in the question units of measure, so that would be words per minute, or words per minute squared. Part B asks us if there must be a value C inside of 0 to 10 such that R of C is equal to 155. And if we look at the values in the table, and again, this is copyrighted information from the College Board, so I'm not going to display all the information here. But if we look at the values of the table, we'll notice that there's a section of the table where we go from 150 to 162, right? And so if this is going to happen, we need to make sure that the intermediate value theorem is in play. And so we were told early on in the given information that function r is differentiable, which therefore implies it is continuous. And we can see right here that the value 155 falls between 150 and 162. And so we would want to articulate that, right, by saying something such as since, I'm not going to write it all out, but since r is differentiable and therefore continuous, right? And since r of 8 is equal to 150, r of 10 is equal to 162, right? The IVT, or intermediate value theorem, guarantees a value C inside of 0 to 10 such that r of C equals 155. So we want to make sure we hit on those conditions for the intermediate value theorem, which is continuity, right? Also the values of R8, R of 10, just to kind of add those values in there to show that 155 lands between those. Go to part C. Okay, part C says we're going to do a trapezoidal sum, 3 subintervals, and we're going to use that to approximate the value of 0 to 10 of R of t. Okay, now the important thing here is that there were unequal subintervals in the table, so we have to be a little careful. But that sum that we're going to get is going to be 1/2 times the first height times the values of the first 2 points. Going to add that to the next interval. We're going to go 6 on this one. That would be 250. And then the third interval also has a height of 2, and total of 312 for the bases, right? And all of that leads us to about 2504 over 2, or 1252 words per minute. Oh, I'm sorry, words. Okay, now part D kind of takes this and adds on to it, and this time we're talking about a teacher who reads at a certain rate. And we were asked to go off of the model and find out how many words the teacher has read at the end of the 10-minute period. Here's the teacher's rate. It's given as WT equals -3/10 t squared plus 8t plus 100. So we are going to need to integrate that from 0 to 10. It's actually a pretty easy one, polynomial to integrate, so simple power rules here. And when all is said and done, we find that the teacher has read 1,300 words. So there's question 3 on both the AB and the BC exam.